For eons, humans have valued certain substances more than others. Nearly every culture on Earth has a history of using semi-precious stones for currency or religious rituals. Until recently, many countries even used the gold standard as a basis for their currency. But while materials like gold, silver, and bronze are the most commonly referenced precious substances, they are far from the most valuable. From radioactive isotopes to ultra-rare elements, we are counting down the top 10 most expensive materials on Earth. Lysergic acid diethylamide, better known as LSD or its street name acid, is the single most popular synthetic psychedelic drug in the world. First synthesized by a Swiss scientist in the 1930s, it was popularized in the 1960s by counterculture icons like Ken Kesey and Timothy Leary. Their goal was to make the substance free and available to the general public, but more than 50 years later it's still one of the most expensive materials in the world, selling for an average of $2,500 a gram. Part of the issue is that a very small dosage is necessary to attain psychoactive effects. The average dosage of LSD ranges from 100 to 200 micrograms, meaning that a dealer will sell almost 10,000 doses in a single gram. While the 60s counterculture movement used the drug to escape the problems of society, the Western intelligence community and the military saw it as a potential chemical weapon. In 1951, these organizations began a series of experiments. U.S. researchers noted that LSD is capable of rendering whole groups of people, including military forces, indifferent to their surroundings and situations, interfering with planning and judgment, and even creating apprehension, uncontrollable confusion, and terror. Experiments in the possible use of LSD to change the personalities of intelligence targets and to control whole populations continued until the United States officially banned the drug in 1967. Since then, it's only been available in the black market, driving up its price. Plutonium is a radioactive element first discovered in 1941 by a pair of American scientists. It's most well known for its role in the Manhattan Project, in which the American military built the world's first atomic bombs. The Fat Man bombs used in the Trinity nuclear test in July 1945 and in the bombing of Nagasaki in August 1945 had plutonium cores. Human radiation experiments studying plutonium were conducted without informed consent, and several accidents, some lethal, occurred after the war. The element is extremely unstable and difficult to handle, meaning that a handful of scientists on Earth have access to it. This rarity causes the price to rise, in this case to $3,900 a gram. The secondary use of plutonium is for energy production. Plutonium-238 is used to make electricity for space probes using radioisotope thermoelectric generators. These generators are switched on when the probes can't get enough solar power because they've traveled too far away from the sun. Some probes that use plutonium-238 are Cassini and Galileo. According to the World Nuclear Association, over one-third of the energy produced in most nuclear power plants comes from plutonium. Plutonium is the main fuel in fast neutron reactors. However, plutonium has an incredibly long half-life, and there is already an environmental crisis surrounding where to put the remnant waste. When you think of precious stones, you're likely thinking of sapphires, rubies, and emeralds, but one stone is worth more than all of these, despite being lesser known. Found almost exclusively in Myanmar, painite can easily fetch the astounding price of $8,500 a gram. Painite is named after Arthur Charles Davy Payne, English gem collector who first recognized the mineral. Painite forms elongated, transparent, deep garnet red crystals. Pleochlorism is ruby red and pale orange or red orange. The first painite specimen, a single crystal, was identified as a new gem species in 1957. Until 2001, only 2 more crystals were found. Since then, more painites have been discovered. Over 1,000 crystals and fragments have now been recovered, but most of this material isn't usable in jewelry. Painite's extreme rarity is due to it containing the chemical elements zirconium and boron, which do not normally associate with each other in nature and don't occur together in any other mineral. Ironically, some painite crystals are partly altered to a crust of small pink crystals of the more common ruby. While it is still far from a household name, painite will continue to be extremely valuable until more is found. Red beryl is an extremely rare variety of beryl that receives its red color from trace amounts of manganese. In the entire world, crystals suitable for cutting gems have been found in only one location, the Ruby Violet Claims in the Wawa Mountains of Beaver County, Utah. The Utah Geological Survey estimated that 1 crystal of red beryl is found for every 150,000 gem-quality diamonds. The raspberry red crystals were first discovered in 1904 by the mineralogist Maynard Bixby and named Bixbyte in his honor. The term has since been discouraged by the World Jewelry Confederation to avoid confusion with the rare black mineral Bixbyite, also named for Maynard Bixby. Though red beryl is now the more accepted term, the trade name Bixbyte is still in use. Red beryl is a rare mineral because its formation requires a unique geochemical environment. First, the element beryllium must be present in large enough amounts to form minerals. Second, manganese must be present and available at the same time and location. Third, the correct geochemical conditions must be present for beryllium, manganese, aluminum, silicon, and oxygen to crystallize into red beryl. For gem-quality red beryl to form, fractures and cavities must also be able to serve as a space for nice crystals to grow. The rarity of red beryl means it regularly fetches $9,000 a gram. Taphite is a gorgeous and incredibly rare mineral in gemstone. Its color is usually a lilac or mauve, but can also appear as a brownish red, pink, purple, bluish green, as well as transparent. The story of its discovery is different from any other gem. It was discovered by Austrian gemologist Richard Taffy in 1945 as cut and polished gem samples in a jeweler's shop in Dublin, Ireland. Before Taffy found this new gem, taphite was wrongly identified as spinel, a group of magnesium-aluminum minerals. Taffy noticed that unlike spinel, these stones showed signs of double refraction. He took the samples to B.W. Anderson of the Laboratory of London Chamber of Commerce to identify the stones. It wasn't until 1951 that a chemical and X-ray analysis showed that taphite was not spinel and in fact a new rare gem. Now that taphite has been identified as a distinct species, more taphite is being discovered. To date, Sri Lanka, Tanzania, and Burma have been the only sources for this material, with most samples coming from Sri Lanka. But it is expected that taphite specimens may eventually be found in other spinel mining locations, such as Madagascar. Taphite is sold for a standard price of $20,000 for a single gram. Tritium is a radioactive form or isotope of hydrogen. It has two neutrons where regular hydrogen does not have any, which makes tritium unstable and therefore radioactive. It is produced naturally from interactions of cosmic rays with gases in the upper atmosphere. Tritium emits electrons through beta decay, and when they interact with a phosphor material, light is emitted through the process of phosphorescence. In layman's terms, that means that its substance actively produces light. In certain conditions, it can be seen glowing in a variety of colors. Miraculously, this radioactive substance does not pose a serious health threat to those who use it. Tritium is a relatively weak source of beta radiation. The beta particle itself does not have enough energy to penetrate the skin. However, it can pose a health risk if taken directly into the body in extremely large quantities. For example, a person would need to take in billions of becquerels before seeing a health effect. Direct short-term exposure to small amounts of tritium is mostly harmless. If a tritium tube breaks, one should leave the area and allow the gas to diffuse into the air. Tritium exists naturally in the environment, but in very small quantities. Tritium is also used as a tracer in biomedical and academic research. Some countries use tritium as fuel for thermonuclear weapons, although many are committed to nuclear nonproliferation. In the future, tritium may also be used to generate electricity in fusion reactors, which are currently under development. Tritium is sold for an astounding $30,000 a gram. Here's a familiar substance with a notoriously high price tag. Diamond is the most concentrated form of pure carbon in the natural world, and the strongest mineral on Earth, far exceeding other carbon allotropes such as graphite and fullerite. The secret to diamond's superior strength is found on the molecular level. Diamonds require environments of at least 752 degrees Fahrenheit and 434,113 pounds per square inch. The most favorable diamond-forming conditions can be found about 100 miles underground. Hundreds of millions of years ago, eruptions of magma from the mantle propelled natural diamonds closer to the Earth's surface. The funnel-shaped areas carved out by the magma eruptions are called kimberlite pipes, named for the first formation discovered in Kimberley, South Africa. The rarity and the scarce supply of diamonds have made diamonds a precious commodity. Of course, the advent of lab-grown diamonds has lowered the price, and there's a huge discrepancy depending on the quality, but diamonds are regularly sold for $50,000 a gram. The most authentic man-made diamonds today are manufactured by subjecting pure carbon to intense heat and pressure in a simulation of the organic process. To the naked eye, these synthetic diamonds are indistinguishable from natural ones. Coming in at number 3 is californium. Californium is a synthetic radioactive element not found in nature. The pure metal is silvery white, malleable, and so soft it can be easily sliced with a razor blade. Californium is moderately chemically reactive. It slowly tarnishes in air at room temperature. Small pieces of the metal begin to oxidize, but not violently. The element was first synthesized in 1950 at the Lawrence Berkeley National Laboratory by bombarding curium with alpha particles. The principal use of californium is in nuclear power plants, though a majority of plants use plutonium. Californium-245 is the source of radiation for the treatment of a wide variety of cancers. The medical community was struggling to effectively treat cervical cancer using radiation therapy. When they started using californium-245 to bombard tumors with neutrons, more lives were being saved. Californium-245 neutron therapy involves inserting a californium-245 implant near the tumors, so the neutrons strike the tumors more directly, which saves the healthy surrounding tissue from being damaged by the treatment. Because of its rarity and potential use in both the realms of medicine and power, californium is sold for around $27 million for a single gram. This one's a mouthful. Fullerenes are a remarkable class of molecules in which large numbers of carbon molecules are locked together into a roughly spherical shape. Their construction roughly resembles the interlocked trusses of Buckminster Fuller's famous geodesic domes, which is why these molecules are called fullerenes, or buckyballs. In the medical field, elements such as helium can be used as chemical tracers in impregnated buckyballs. Water-soluble derivatives of buckyballs were discovered to exert an inhibition on the 3 isoforms of nitric oxide synthase, with slightly different reactions. The optical absorption properties of buckyballs match solar spectrum in a way that suggests that Buckminster Fullerene-based films could be useful for energy sources. Although they are fascinating from a purely scientific point of view, their utilitarian value is not so clear. According to an expert, to date, no products based on fullerenes have had a significant financial impact. That's not to say that such products will not ever exist. It's only to say that the fullerene-based field of materials research is young, that opportunities remain to be explored and exploited, and that the jump from discovery to widespread application takes time. Even though they do not yet have a specific use, they are the source of ongoing testing and are worth $150 million a gram. Coming in at number 1 is an extremely mysterious substance. Even understanding antimatter requires a good deal of explanation. Every particle has an antiparticle with the same mass but the opposite electric charge. The proton has the negatively charged antiproton and the electron has the positively charged antielectron, or positron. The Big Bang should have created equal amounts of matter and antimatter in the early universe, but today everything we see, from the smallest life forms on Earth to the largest stellar objects, is made almost entirely of matter. Comparatively, there's not much antimatter to be found. Something must have happened to tip the balance. One of the greatest challenges in physics is to figure out what happened to the antimatter, or why we see an asymmetry between matter and antimatter. Antimatter particles share the same mass as their matter counterparts, but qualities such as electric charge are opposite. The positively charged positron, for example, is the antiparticle to the negatively charged electron. Matter and antimatter particles are always produced as a pair, and if they come in contact, annihilate one another, leaving behind pure energy. During the first fractions of a second of the Big Bang, the hot and dense universe was buzzing with particle-antiparticle pairs popping in and out of existence. If matter and antimatter are created and destroyed together, it seems the universe should contain nothing but leftover energy. Because of its mysterious nature and myriad potential uses, NASA estimates that antimatter is worth $62.5 trillion for a single gram.